Hey there, and welcome. Today we're going to crack the code on the backbone of pretty much all modern technology, system analysis and design. So let's jump right in.
Think about it. You have an idea and then somehow it turns into this fully functional app on your phone. It can feel like magic, right? Well, it's not magic at all. It's actually a structured, pretty fascinating process, and that's the journey we're going to take today.
Before you can build anything, you need a blueprint. And for us, that means we have to start with the most basic concept of all. What exactly is a system?
Okay, that sounds a bit like a textbook definition, so what does it really mean? Well, at its heart, a system is just a bunch of different parts that are organized to work together for one specific reason. Nothing is random. Think of a university. The students are the input, the whole education process is what transforms them, and the graduates are the output. Every single piece, from registration to the final exam, works together to achieve that goal.
And this diagram really breaks it all down for us. You've got an input, that's your raw data. You've got a processor, that's the engine doing all the work. And you've got an output, the final result. But look, you've also got things like control and feedback loops. Those are there to make sure the system actually stays on track and does what it's supposed to do.
So, these properties, they're basically the DNA of any system. It's got a structure, all the parts interact and really depend on one another, and everything is pulled together, integrated, to hit one central goal. And hey, if you can start spotting these things, you're already on your way to thinking like an analyst.
All right, so we get the blueprint, but who's the architect that actually designs it? Well, that's where the system analyst comes in.
This role is so important. The analyst isn't just some tech guru, they're a translator. They listen to what the business and its users actually need, and then they turn all of that into a technical plan that developers can look at and say, okay, I can build that.
And to be that effective bridge, an analyst needs a pretty diverse toolbox. So on one side, they need strong technical skills to know it's even possible. But on the other side, they have to have sharp business skills. Because let's be real, you can't build the right solution if you don't truly get the problem you're trying to solve in the first place.
And it doesn't stop there. An analyst needs amazing analytical skills to break down complex problems, great interpersonal skills to talk to everybody from the CEO down to the end user, and solid management skills to keep the whole project from going off the rails. It's this really cool blend of logic, communication, and leadership.
Okay, so we've got the system and we've got the architect. But what about the master plan they follow? Well, that plan has a name, the System Development Lifecycle, or as you'll hear it called all the time, the SDLC.
Just think of the SDLC as the recipe for building software. It's a structured process that takes this huge, overwhelming task of creating a system and breaks it down into a series of predictable, manageable steps. It's all about making sure nothing important gets missed along the way.
This diagram shows us the entire life story of a project. It all kicks off with planning, where the initial idea gets a green light. Then we dive into analysis, which is all about figuring out what the system really needs to do. In design, we map out what the solution will look like. Implementation, that's the fun part where the code gets written. And finally, maintenance, which makes sure the system keeps running smoothly long after it's launched.
Now, there isn't just one way to do the SDLC. Two of the big ones you'll always hear about are waterfall and agile. Waterfall is like building with Legos, using the instructions. You have to finish step 1 before you can move to step 2. It's super structured. Agile, on the other hand, is a lot more like sculpting. You work in these small, quick cycles, constantly getting feedback and making changes. It's all about being flexible and adaptive.
So what kind of tools and tricks does an analyst use to actually get the job done during all these phases? All right, let's pop open the toolbox.
A huge part of an analyst's job is basically being a detective. They have to gather information, facts, from every possible angle to understand what users truly need. So that might mean doing interviews or sending out questionnaires, or it could be more subtle, like just watching people work or reviewing old documents. Sometimes they'll even whip up a quick prototype to show people and get their gut reactions.
And here is a classic tool from that toolbox, the Data Flow Diagram, or DFD. It's basically a simple visual map that shows how information flows through a system. And you know what the real magic is here? It's simplicity. It creates a common language so that everyone, from the tech team to the managers, can get on the exact same page about how the system is supposed to work. Okay, once this system's built, you can't just ship it. You have to test it like crazy. And that happens in 4 key stages. First up is unit testing, where you check the tiniest little pieces of code. Next, integration testing. Make sure all those little pieces actually play nicely together. Then, system testing looks at the entire system as one complete thing. And finally, the moment of truth, acceptance testing. That's where the actual user gives the final thumbs up and confirms, yep, this is what I needed.
Whew, okay. We've covered a lot of ground. What systems are, the analyst's role, life cycles, and all these tools. But why does any of this actually matter?
Because at the end of the day, it all boils down to this. We don't build software just to build software. We build it to solve a real human problem, to make someone's job easier, to connect people, to help a business grow. System analysis and design is the discipline of making sure we're building the right solution for the right problem.
So now you have the fundamental building blocks. You've got the blueprint for a system, the mindset of the architect, and the master plan of the SDLC. The only question left is, what problem are you going to solve? Thanks for digging into this with me.